So today we're gonna discuss about the field axioms, and these field axioms are generally written in additive and multiplicative pairs. So we have associative, commutative, distributive, identity, and inverses. So with that, we can create a table to understand or to remember this field axioms more. So we have addition, as what I've said earlier, and the multiplication. So in addition of associative, we have this form. And in its multiplication, we have this form. For commutative, we have this form. And in multiplication, we have this form. For distributive, in addition, we have and for multiplication, for identity, we have the 0 and 1. And for the inverses, so take note of this table first for us to identify or understand these field axioms. So explaining further, we have to move this. So first, let's go further on associative. According to the table, we have this form. So this works for addition. Like for example, we have x plus 5 plus 2 is equals to 0. So this equation is in this form, which is also equal to x plus 5 plus 2. So this arrangement will be much easier for us to solve. So this field of axioms actually helps us to reform or rearrange the equation for us to further solve this equation better. So solving this equation, we have 5 plus 2 is equals to 7. So here it is. That is how associative works. For multiplication, we have this form. So an example of this is 2x times 6. So if we're going to rearrange that in this form, this is also equal to this form is easier to solve. So this will be equal to x. 2 times 6 is 12. So we have this 12x. So that is how multiplication of associative works. The next one is commutative. In addition, we have this form. In this particular form, we can have an example of x plus y is equal to y plus x. So they're just the same. Another is 6 plus 7 is also equal to 7 plus 6. So that is just how commutative property works. And in multiplication, AB is equals to BA. So like for example, we have x times 10. So if we're going to rewrite that in this form, we can have 10x. So they're just the same. So for distributive, we have this form. Like for example, we have x and y plus 7. So if we're going to distribute this x, we will have xy plus 7x. So this form is also the same to this one. In identity, we have 0 for addition and 1 for multiplication. Why is that so? So in addition, if we add 0 to any number, we will get the exact same number. So if we're going to add 0 plus 0, we will have the result of 0. So if we add 1 million to 0, we will still have the value of 1 million. So that is how 0 works in identity. But what about the multiplication? So any number that is multiplied to 1 is also equivalent to the same number. So if we have 565 multiplied to 1, if we're going to multiply that to 1, we will have the same result as 565. If we're going to multiply 0 to 1, we will have the result 0. So that is how identity works. Last but not the least is the inverses, wherein it has a form of, if we add the same number to the negative of it, we will have the value 0. And if we switch that up, we will still have the value 0. So like for example, we have 6 plus negative 6. So this will be cancelled out. just like here in this integer. So if we're going to add this up, so 1 2 3 4 5 6, so this is approaching to 0 and this is approaching to 0, so we will have the result 0. So if we're going to reverse or inverse the value, we will have this equation, which is also the same result as the first one. For the multiplication, we have this form. Like for example, we have 8 times 8 to the negative 1. So if we're going to raise a number in negative 1, we will have the reciprocal value of it. So this is also equivalent to 1 over 8. And this will be cancelled out and 1 will remain. So this is equals to 1. So if we try this out, we will also get the value of 1. So 1 over 8 times 8, cancel that out, we will have the value 1. This is only possible if a is non-zero. So let's try 0 to see why it is not possible. So 0 times 1 over 0. So this is actually undefined in calculator. That is why it is not possible to use in inverses such number.